Next question. Show that rationals are closed under addition and multiplication. So what's the meaning of that? It means that if P and Q are two rationals, then P plus Q and also P times Q are rationals as well. So how do we prove that? Let P be A1 over B1 and Q, as we defined, rational numbers, A sub 2 divided by B sub 2, and note that these numbers are all integers, A1, A2, B1, and B2, all are integers, and the denominators are not zero. And B1 and B2, they are not equal to 0. First, we're going to add these together for addition. P plus Q is equal to A1 over B1 plus A2 over B2. So let's take common denominator between them, B1, B2. So you get A1, B2 plus A2, B1. Now let us stop and analyze this. On the numerator, you have multiplication of two integers. A1, B2 is an integer. What else? A2, B1 is also an integer. The sum of two integers is also an integer. A1, B2 plus A2, B1 belongs to Z. So far, your numerator is an integer. Remembering the definition of a rational number. And the denominator, B1 and B2, both of them are integers, so as B1 times B2. And at the same time, since B1 and B2 are non-zero, you can conclude that B1 times B2 is non-zero. So by definition of rational number, P plus Q belongs to Q, or P plus Q is an integer. What's the meaning of that? It means that the rationals are closed under addition. So Q, bolded letter Q, is closed under addition. Remember that we can generalize the idea to subtraction. So subtraction also good here. What about multiplication? Now for multiplication, we're just going to multiply P and Q, right? It's very easy. A1 over B1 times A2 over B2. So obviously it's going to be A1, A2 over B1, B2. But there's the same analysis, the same rationalization. A1 is an integer. A2 is an integer. So their product, as we know, is an integer because integers are closed under multiplication. B1 is an integer. B2 is an integer. We can conclude that B1 times B2 is an integer. And at the same time, we know B1 and B2, both of them are not zero. So B1 times B2 is not zero. It fits into the definition of a rational number. So by definition of a rational number, P times Q belongs to Q. What's the meaning of that? So Q, or the set of rational numbers, is closed under multiplication. But it's not true for division here. For division, I'm using a different color to have your attention. Division doesn't work. You can find a contradiction. For example, I'm going to give you P equals to just a rational number, like 1. Remember, 1 can be written as 1 divided by 1, so it's a rational number. And I'm going to take Q to be equal to 0. What is P over Q? 1 over 0. You're allowed to do the division here because you're taking two random rational numbers. This guy is not a rational number. Does not belong to Q. So it's not, Q is not closed under division. We have to restrict ourselves to non-zero rationals. Non-zero rationals are closed under division as well. So let us quickly write this down. Non-zero rationals are closed under division. So when we're talking about non-zero rationals, we are excluding 0 from rationals. Q minus 0. Non-zero rationals or Q minus 0 is closed under division.